Share the power. Okay. So, what I'm going to do here today, folks, is I'm going to talk to you about uh, Kubernetes, Azure Kubernetes service in particular, and what I'm going to basically talk about is the background to it, where it came from, why it is, and why you guys should be using it. So before we get stuck into that, I'm going to give you some brief background on myself. So I'm the very handsome Santa Claus-like chap beaming out of your screen there. I'm an engineer, which means that I'm obsessed with understanding how things work and with making things. And you know, when we're talking about Kubernetes and Docker and serverless and all this type of stuff, it's very much a case of if you understand how it works, you can use the power of it much better. You don't need to go in there and to develop it, but you need to understand where it came from, why it's there, why it exists, and what the Azure Kubernetes service adds to Kubernetes and Docker itself. So I'm a CTO of a company called the DataWorks, and we mostly play with big data and machine learning. And this is one of the reasons that I became deeply involved in Kubernetes, because it offers such immense opportunity and goodness for folk who work with big data, who work with applications that have to scale quickly and easily, and people who want to put managed services into their pipeline. My most prized award is the one that I got from C# Corner for being a most valued professional member of the community. And C# Corner, as you know, it's not simply online, it's also offline, apart from our COVID days right now. And in a serious way, these folk organize local meetups, they promote technology, they promote diversity and inclusion, and there's millions of members across the world. So my message from this slide here is that I'm speaking to you, I'm giving you some of my time, I'm giving you some of my expertise. I'd like you who are watching today, if you don't already, to strongly consider giving back to your tech community. It's not difficult. Just start by answering some questions online, write an article, considering sharing some of your knowledge with fellow techies, either virtually or when we get back into whatever the new normal becomes with physical meetups and physical people. And the biggest message that I want to give everyone, at the start of this slide here is that knowledge must be shared for the good of everyone. So do your best to share your knowledge and to help others. So let's talk about Azure Kubernetes Service, or AKS, as it's also called. The agenda that we're going to look at today is we are going to talk about the history and the background of Kubernetes. We are going to talk about the Kubernetes and containers themselves, what they are, what they do. We're going to cover some basic Kubernetes fundamentals. We'll then talk about AKS and what it brings to the party, and then we'll go through any Q&A that you might have at the end. The very first website that I was involved with was back in the late 1990s. And at the time, the project undertaking was absolutely huge. And I mean, really, really big. You wouldn't think it, but if you look at some of the websites that were around from the big boys like Apple and Microsoft at the time that I have there on the screen, you'd look at those and you go, goodness, well, isn't that the type of thing that a kid puts together in code camp, like in an afternoon or a weekend? They look so basic. And but the thing is, to get to that stage there took a huge amount of effort and a huge amount of money. And what we're going to do now is we're going to talk about the evolution of this stuff over time. So when I did my first website, having decided what the service we were providing was going to do, what was going to be, we put together a project plan and a budget. And at the time, our project costing estimates were, well, it was going to cost us $250,000, $250,000 to purchase the servers. It was going to cost us to host those servers and bring the internet pipe into our office, because there was no data centers really. It was going to cost us $75,000 for a fast ISDN line, which was, I think, 32K. And the engineers and other people-related costs, it was going to take us about 30 to 40 people to bring this all together, and that was going to cost us about 350,000. And to ensure that we gave our project success, we moved the new office then near to a digital exchange at the time, so we could get a guaranteed 128K speed internet connection. So as you can see, it was a very big project. Well, it really was back in the 1990s, right? Now, don't get me wrong. I mean, this wasn't something that was completely out of the dark ages. We didn't have punch cards and the like, but it was a very big project for the time. And if you converted it back to today's projects, well, it was just a basic website. But back then, it was such a big deal. It was like something you would make your career on. You would say, I did this big project, and it was, $750,000, and et cetera, et cetera, et cetera. But in retrospect, for what was a very, very pretty basic website, it was at the time extraordinarily complex to do. And it was big, really big, and it used very big resources. And in the background picture that you can see there on the slide, when you see those big physical racks and the power units and everything else, that's exactly what we had, right? Now you could fit all that into an iPhone, right? But back then, that's what we had. And this was not cheap stuff. It was extremely expensive. So last week, I had an idea for a new SaaS website. And after spending, the bones of 45, 60 minutes slapping together a React.js, an entity framework into place and spinning up my CRUD, and what I did was in Visual Studio, file new website. And my website was up. Like within 4 or 5 minutes, I had a website that was up, deployed, and done. And it cost me almost nothing. You get your free $25 a month from Microsoft under the different programs, and I just did that. So I put up the equivalent of what cost us over $500,000 and took months and months and months to push through in completion back when I started in IT. And I published one in a few minutes, and it'll just overall cost me less than $1 a month to run, and that's absolutely incredible. So the days that we had to publish into, and a lot of you will remember this, publish into a particular folder and then FTP the code or the DLLs and all of the supporting files up to your service hosts and beg them, to please allow you to include some kind of non-standard plugin or DLL that you really, really needed for this particular website so that I could get paid, and then hope that everything connected together and worked and that the website would deploy. Only the gods themselves could help me if something went wrong or something went right, because there was very little support for logging and debugging on the machines that you uploaded to things at that stage. And even now, some hosts are still in the dark ages when stuff like that went wrong. So how did we get to this stage? How did we get to this stage where we can do this amazing web stuff at the speed of light? And what exactly is containers and Kubernetes and serverless and cloud functions? What's all that kind of stuff and how is it related? So what we're going to do now is we're going to just step through the progression of these things over the few years and see how things emerged. So 15 years ago or so, it was even 10 or earlier, it was very commonplace to have an actual physical server in your office or in your home. And this was directly connected full-time to the web. And by this, I mean that you had a physical server with the fixed IP address that physically sat in your office and was exposed to the web. And some places, they still have this kind of setup, but it's becoming increasingly rare for obvious reasons. And when we wanted to publish a website or expose a service or some kind of thing on the net, it was really easy because we had control. We had direct access to the physical machine, and we could do what we wanted on that machine. We could install this DLL, we could bring up that library, we could have an exotic ActiveX plugin. Does people remember ActiveX plugins, right? The things that your website had to have, or they just simply would not work without. But the problem with this setup is that it's very wasteful, it's expensive, and it left you and the folk in your office, your team, to be the managers of the entire infrastructure, not just the website that you built. And this is a huge deal because not only did you have to be someone who developed the code and the back end and the HTML and the CSS, because of course we didn't have great frameworks like Angular and React and Vue and all these things back then. You also had to be the guy who actually went and took care of the box, and you had to be the DBA guy and all these different things. So it was very, very difficult. So somebody then came up with the idea of renting out rack space in their data centers to people who had their own physical machines and wanted to offload some of the management work of, well, if a disk goes wrong, going over and plugging it in and plugging it out, and that kind of stuff. Offloading your management work in a shared server, in a co-hosted server, meant that you still owned the physical machine, but you could send it to this dedicated space where people knew how to, as it were, keep the lights on for internet-facing servers, and take care of some of the things like backup, fast database connectivity, making sure that the servers were patched, that the security was up to date, stuff that, to be honest, website developers really shouldn't have to worry about, right? This should be like just part of the plumbing at this stage. And the thing about co-hosting your own server, though, is that it's still your own server, right? It's still your own hardware. You still have to buy that thing. It's still going to cost you a lot of money. And while somebody else is managing the machine and all its related overhead issues, it's still not really efficient. Like, the machine is not being used to its optimal, and perhaps 80% of its, 80% plus indeed, of its actual compute life cycle is just spent there lying idle. It's money being wasted that will be put to better use. It could employ a new developer, it could get somebody else to take the pressure off your team, etc. So the next step up in this evolution of computers was and servers on the internet was shared servers. And this is where a rack space company installed some, cool fancy pants server, but on their own operating and hardware systems that allowed them to isolate certain folders and processes and to share resources over a number of different website customers. This had the immediate benefit of using the server for a lot more of the time and at the cost of flexibility to the customer. The customers got access to, and you've seen these things before, a control panel. And we used this to interface with the services that we could install and upload, and it was quite restrictive. And one of the major problems with shared servers is that, as the name says, things are shared. The operating system was shared, the machine resource was shared, the CPUs were shared, the RAM was shared, the operating system and everything on it, all of the different components were shared. And the problem with this is that if one process goes rogue, if something goes wrong, well, then it can maybe hog 100% of the CPUs on the machine for quite some time. And then any other websites or processes that were sharing the space on that machine will suffer as a consequence. And that's not a great situation. So along came another clever person, and they came up with this cool idea of virtual machines. And this is where we have a system that can very specifically isolate part of a server's hardware and present it to the operating system, which sees these isolated parts of the server as another entire server. And when I learned about this, first of all, it just blew my mind, right? Like, think about it. We take a snapshot of an entire machine, an entire server, we break it into chunks, we hand this to a full operating system, and we say, this is all you get. And that's kind of cool, because we could now take a very, very powerful machine, let's say with one motherboard, a gigabyte of hard drive space, 32 gigs of RAM, and virtually split that into, for example, maybe 8 virtual machines with 2 gigs of RAM and 100 megs of hard drive space each, or whatever it happens to be, one of which would be absolutely tons for you to run maybe a reasonable instance of SQL Server, and still have loads of space carved out to run the underlying virtual machine operating system itself. So virtual machines and servers worked really well, and they still do, but they have a limitation. And the limitation is that they're a full-blown operating system environment. And what you need to do is, if you need to create another virtual machine, is you need to spin up another full operating system environment for each and every service that's needed. So despite the fact that we have all of these virtual machines sitting on top of one physical box, it's still a wasteful process, and it's still not optimal on resources. But it's still come a very long way since we had the physical machines in the office, right? So the next step up, and the next major step in the evolution, was the move towards containerization. And what container technology allows us to do is to create an isolated block of resources within a machine, virtual or otherwise, and to share the underlying machine resources without bleeding into the other services that are using the same resources. And that's really important to note, that you can isolate things on the same machine, on the same operating system, without one application or one container affecting the other. So in effect, this is like a shared server, but without the side effect of one installed system having unintended control over another one due to bad resource management. The other major benefit of a container is that you can specify particular versions of system level dependencies. So, you know this thing where you'd go off and you'd write a piece of software on your machine, and then you transfer it to your colleague's machine, and they'd say, no, it doesn't work. And you say, well, it works on my machine. No, it doesn't work on my machine. It complains about X, Y, or Z. Library is not installed, or it's out of date, or it's not up to date, or it's the wrong version, it's incompatible. All those problems go away when you start dealing in containers, right? As I said, you can specify particular versions of system level dependencies. So let's say, for example, that you need to have a particular version of a DLL, a library, another installable. But the problem is that maybe it's custom, or even that it's older, or it's out of date to another system or another application that needs to also share that system on the virtual machine. So that causes a problem. Somebody has to give away. But with containers, what you can do is you can isolate dependencies like this, and you can keep them effectively firewalled from each other. And the added benefit of this is that if something works on your machine, well, then you can take a snapshot of this configuration, and you can transport it to an online host or another developer's machine, and it will still simply work. No questions asked. If it works within a container on your machine, it will work within a container on any other machine that you put it on. And this is an incredibly powerful feature of containers, and it's worth checking out for this particular feature, if nothing else whatsoever. So now we're going to take another little jump upwards before we come back down again. The container paradigm moved us into an area where we can have, let's call them surgically sliced up parts of the operating system just for our simple system. We can use containers to host simple single services, like, for example, an SQL server, or even more complex arrangements of different services in combination. But sometimes we need something leaner again. Sometimes we need something tighter. We need a little simple thing where you think, actually, this one particular part of my system or my architecture would actually be better just being in a shared instance, doing its thing when I need it, but without the overhead of a virtual machine, or even the overhead of having to manage a container. And now you can have your cake and eat it. This is what they call function as a service or serverless computing. On Amazon, they call it Lambda. On Azure, we call it functions. And you now can go in and write a simple function with no supporting website, no container, and just simply say, run this code when some event happens. So functions as a service allow us to write simple functions or methods that does something on the web, let's say, and to deploy it to run without having to worry about the underlying infrastructure, without having to worry about setting up a container or a virtual machine, and without having to worry about all of the usual things that we need to do even to get to a starting point. It's defined as serverless computing because that's actually what it is. It's the ability to write a function or a set of functions in reality and deploy to what seems to us like an environment that has no servers, no containers, nothing. The cloud provider, in this case Azure, worries about the deployment, the isolation, and critically, the auto-scaling horizontally and vertically when it's necessary. Now, unlike virtual machines and Azure platform as a service type offerings, functions aren't charged by the hour, but rather they're charged by the execution of the function on the microsecond. Like that's just incredible, by the microsecond. And that raises a really interesting question. In the past, and now really still, we look at our applications and we say, where's the bottleneck? Where are things actually slowing down? Where can we improve our speed, our process for the customer? What's costing us time and what's costing us money? But now with the introduction of serverless computing and the fact that we're being charged by the function running, we can now look at things from the point of view of saying, what function is costing the business the most money? What function? And that's really, really, really interesting. And I suspect that will bring up a lot of focus on design decisions in the future when we talk about architecture of these types of big applications. But that's aside, that's for a different day's session. So let's say our customer came to us and said, hey, can we implement a simple thing that when an image is uploaded, we check to see if it's in our specified dimensions, and maybe if not, we edit and resize it dynamically to make it fit our requirements. Now, before functions, we would have had to either add this new functionality to our existing web offering in code someplace, integrate it, upload the changes. But with functions, we can simply go into an online editor, define an endpoint, in this case, something to monitor incoming image files, and write some code that would be processed when the image lands. And that's it. There's no hosting setup. There's not even a file new project, for goodness sakes. I mean, you can do that, but it's not really needed. So that's incredibly powerful. So we've gone the full loop from physical servers in our own office through to how they evolved up to functions, serverless. And now we're going to step back a little bit and we're going to look at things from an orchestration and a management point of view, because actually under the hood, these functions as a service, they actually run as specialized containers, if you like, and they have to be managed. So let's go and focus on containers and Kubernetes again. So the job of containers, as we've seen, is to isolate an application and to package up all of the dependencies that the application needs into an isolated bundle, and then to run this in a self-contained, isolated part of the system. So if Docker manages the applications themselves and the communication between the applications inside the containers, what Kubernetes does is it manages the orchestration of those containers. Kubernetes is the thing, it's that glue in the middle that manages the containers on the virtual machines on which they run. It ensures that they have enough CPU and RAM. It ensures that the hard drive space is adequate or will alert if it's not. It will ensure that the containers that need to be close together for quick communications are placed onto the same machine. They're deployed or scheduled onto that same machine or to close networks. And if a container dies, it'll start up a new replica of that container. So it monitors the health of the system and a heck of a lot more. And that's the magic of Kubernetes. It manages the containers so that you don't have to. So if we look back and we compare this to the start of the story when we talked about having a machine in your office where you had to physically go and physically do all the checks and put in the floppy disk and the CD and everything else, right? You have to do all those physical things around the machine. It's almost like the same thing in that Kubernetes is that person who did all those things, right? All you as a developer have to worry about is you deploy your code in the container, shoot the container up to, let's say, Azure Container Services, and then let Kubernetes pull it down and manage it within that. So this is Kelsey Hightower's GitHub repo, and it has a whole set of instructions, step-by-step book, almost, if you like, online, and it's called Kubernetes The Hard Way. And what it does is it talks you through setting up Kubernetes absolutely from scratch. Because the bottom line, my friends, is that Kubernetes setup and management is not for the faint-hearted. It can be quite complex. And one of the things that Microsoft does well is they do very good at automation. They do very good at removing pain. They do very good at removing the things that get in our way that stop us being productive as developers. Because as an engineer, when I look at something, I want to code it. Okay, I don't want to get in there and start messing around with all sorts of settings and pipelines and everything else. I want it to just work. I want to do my creative work and keep driving that forward, right? But Kubernetes is an absolutely fantastic and awesome system, and it runs some of the biggest services on the planet today, and will continue to do. It's only growing bigger, but it is not an easy system to work with, okay? It is not an easy system to work with, and Kubernetes setup and management is hard. And this is one of the reasons that Kelsey's website there says Kubernetes the hard way, because it's difficult. It's a bit like hardware. You know, we have hardware and we got software. Like there's a little hint there in the name, hardware, because hardware is hard, right? Kubernetes setting up is also hard. So if you look here at this diagram, what we're looking at is three machines. We call them nodes. One is running CentOS, the other is running CentOS, the other is running CentOS. So three machines running CentOS. That's the Cent operating system version 7. And each of those has a particular role, and each one of them runs containers. If we didn't have Kubernetes, we would have to dial in and manage those machines ourselves as we deploy the containers onto them. Kubernetes does that management for us. Before I continue, I'm just going to check with on the website here and to make sure that we're actually doing okay on time. So can you just give me a ping there, Stephen, in the chat window to make sure that I'm okay? Because I don't want to run too much over or under time. Yes, I think we're doing good. That's fine. So we're doing good. Okay, so let's go back here now. And in this here, we can see that we have 3 virtual machines and we have Kubernetes managing. And it seems reasonably clean there, okay? It seems like there's not a lot to do. Now I'm going to show you another screen. And this screen here shows a little bit more of what's actually going on inside in the Kubernetes network when we have it running and what it's actually doing. So this looks a little bit more complex, right? So In Kubernetes, we have two main types of machines, or nodes, as they're called. We have a master machine, a master virtual machine, and then we have node machines. Now, these guys used to be called, and they weren't called nodes. They were actually previously called minions, from the Minion cartoon program. I thought it was really cool. I prefer them to be called minions, but they've changed the nodes, and that's the way it is. In any case, what you can see here is that in every node, we have a stack, which is first of all the operating system. On top of that, we have the container runtime, and this is the thing that runs the actual Docker containers that have our applications. On top of that, we have a thing called a kubelet, and a kubelet is a small application that runs like a daemon. It runs as a service on the nodes, and it continuously communicates back and forth to the master Kubernetes node, reporting on the health of the system, reporting on the containers that are running, what type of CPU they're taking, how much space they're taking, all these different things. Above that, again, we have the networking layer, and we look at networking a little bit later in a live system I'm going to demonstrate to you. And if you look at the different color of the arrows, right, of the information going up and forward, you'll see that it uses a number of different types of network message communication protocol. It uses JSON message exchange on REST APIs. It uses gRPC, it uses core protobufs. So an awful lot going on there. By the way, if you are doing a lot of high-speed messaging, I would recommend that you look at gRPC and protobufs. They're absolutely awesome from a speed point of view. That aside, let's go back to the picture here. So on the top then, the master machine, it has a number of different services that it runs and it manages. First of all, it has an API server, and this is to allow the different nodes via the kubelets to communicate back to it so that it knows what's going on all the time. Then it has a scheduler and a control manager, which decides exactly what container should be running where, how many there should be, etc., etc., and it keeps those all ticking along. But the bottom line here to note is that the container part, the container runtime, is an extremely small part of this entire process. And what you can see there in this high-level diagram is actually quite a complex environment. There's a huge amount that's actually going on there. Kubernetes is hard. So what Azure Kubernetes Service does is it comes along and it manages the hard stuff for us. Okay, it takes away the pain, and there's a lot of pain if you try and do it yourself, trust me. It takes away the pain, and it does all of these things for you. It ensures that the virtual machines stay up. If one goes down, it will deploy another one. It will ensure that it gets filled out with the right containers. It will auto-scale them. It'll keep your machine healthy. It'll keep your security up to date. Every single thing that you would normally have to do as a person tweaking Kubernetes manually, Azure Kubernetes Service takes care of for you. And that's incredibly important. So some of the key benefits of using Azure Kubernetes Service, at least to me, like most of Azure, is that we have incredibly tight integration with all of the other Azure services that we know and love. So we have, first of all, elastic provisioning, and we can use a tool that Microsoft have generated and given out as open source called Kida. And Kida is really interesting because what it is it's an event preprocessor, and it's a system that can look at a queue. So it can look at a queue of work that's coming down into your system, into your app, and it can make a decision based on the amount of work in that queue. So the amount of work coming down into your app that's spread across many containers, it can say, I think that this particular system is about to explode. I think this particular system is going to need to grow really, really fast, really quickly, because maybe you've just put an advert on TV. Maybe it's been on Super Bowl Monday or something. Maybe it goes out at the most as an advert on the most popular reality TV show, and suddenly everybody says, "Oh, we want to go and we want to use this service." So as all these people hit your endpoint and those messages come into your queue, Kida can look at those coming into the queue and can say, we need to auto-scale this system up so it can grow your system. You don't have to do this. You don't have to go in and manually trigger up Kubernetes. AKS will take care of this for you. You just need to configure it, give it the boundaries, because we don't want our budget to be blown either, right? And it'll take care of that for us. The other thing that it does is it takes care of very tight integration with our Azure DevOps. And this is one thing that I use very heavily myself. So all of the code that my company uses, we push into Azure DevOps. And we have our ticketing system in there in Azure Boards. We use Azure Container Services. We have everything tightly integrated. And this means that when I go in and I write a ticket for one of the engineers on my team to say, go and do this particular thing here, they go off and do it. Well, when they do a push on Git, they put in a flag in the comment to say that it's attached, that this particular push they're doing for a PR request is linked to a particular job. So it's linked to a particular task that I issued to them on the board. That gets in, the other members of the team, they'll check the PR and that's accepted. And then it gets pushed up and it goes through and it gets integrated into the overall system, gets pushed up into Azure Container Services, and then gets automatically deployed down into Azure Kubernetes service itself. So for me, one of the huge wins here is the end-to-end tight integration that we have. The other thing it does is it integrates very tightly with Azure Active Directory, which means that we can have our inbuilt security layer very, very tightly. And the other benefit that it has is it is in more regions than any other cloud provider that we have at the moment. So earlier on, I talked about having to have numerous people involved in the process to get our application up and running. We talked about having IT pros and the DBA and the security guy, all of these different folk involved. But the beauty of using an integrated service is that we can now automate all of this and put it into a pipeline. And this is what my company does. All of our work is in one smooth pipeline. Everything gets taken care of from end to end. So now we can easily define, deploy, debug, and upgrade incredibly complex systems and automatically containerize everything. We can ensure that all of our routine tasks are automated and that we have a very, very deep level of traceability across everything in our deployments. And this is incredibly important. You can see there from the diagram on screen where we can start out and we can send everything in through the repos. They can come up, it can automatically do a continuous integration and deployment. It can go and it can automatically pull down, deploy into and pull down from the Azure Containerization services. It can kick that then into the Azure Kubernetes production cluster. Everything is automatic from end to end. And this is one of the, for me, the huge draws of AKS integrated with everything else. Deploying your code into Azure Kubernetes service is extremely easy. Like, it just could not be easier, both in the large Visual Studio and in the lightweight Visual VS Code itself. So this screen, for example, shows how I can make one request and will deploy my code directly up to a container, running my code up on the cloud and push it through all those loops in my predefined pipeline. And I don't have to worry about this, right? So this is the beauty of the managed service. The other thing is that if you recall, we talked about how Azure Kubernetes service removes the pain of managing all of these virtual machines that sits under Kubernetes. Well, this is how easy it is. We can define the type of machine that we want, and then we can either choose to manually update these ourselves, or we can let Azure auto scale this with certain criteria, potentially hooked into the likes of Kida to push that along for us, which is pretty awesome. So what I'm going to do now is I'm going to show you, give you a little peek inside one of my own systems of things that's going on inside a Kubernetes cluster. In this case, this is a Kubernetes cluster that's managed by AKS. So I'm going to investigate it through a thing called Weavescope, which is a tool for examining the network, and show you some of the different things that's going on. And I think by looking at this here, you will see the complexity of Kubernetes. You will see the huge amount of things that it has to manage, and you'll understand why you do not want to do this yourself, right? You'll understand why you want to use Azure Kubernetes Service or another similar managed service. But importantly, you'll want to get somebody else to manage this for you, because you don't want to spend your time here unless that's what you want to do. And if that's what your thing is, that's awesome. Go for it. So what I'm going to do now is I'm going to skip over, hopefully, to my live screen here and see if I can pick it up. Let me see if I go here and I click out of this. I think I'm now in Weavescope. So I'm just going to double check with the guys here to confirm that they still have that. So Simon, Stephen, you have the correct desktop there at the moment. I did this last week and I turned out I was showing the wrong desktop. So you should be seeing a thing called Weavescope, and you should see my mouse moving around now. Weavescope, awesome. Okay. So what we're doing now is we're looking inside a live Kubernetes instance. And this particular thing here has a number of services inside. It has a thing called Grafana, which is a dashboard system. It's got Jupyter Lab, which is a system for machine learning and working with AI. It's got then a certificate manager. It's got Superset, which is a database visualizer type tool. We have Cassandra database over here. We have Redis over here. We got Mongo over here. So there's a huge amount going on here. Okay, we can see an awful lot going on here in this particular system. And what I'm looking at here now is I'm looking at the containers live as they're working across my system, which is why you're seeing things move in and move out. What I'm now going to do is I'm going to show you the underlying machinery underneath this, and I'm going to do that by clicking on the hosts button up here at the top. So if I click on hosts, as it goes and it updates here, it sees that I have 1, 2, 3, 4 hosts. Okay, so there's 4 hosts that I have, and each one of these is running Kubernetes, and they're all managed by AKS. Now, if I go to one particular host, this first one here, I'm going to click into it, and it will bring up the properties on the right-hand side here. And inside this, I can get information on what's happening on this particular host. So you can see here that it's using a small amount of memory. The overall load is less than 0.5%. CPU is less than 4%. If I look down here and see what containers are on the machine, it tells me exactly what containers are deployed onto this machine at the moment. And I can see also what processes are running on the machine. Now what I'm going to do is I'm going to click on a different machine. So we can see here that there's Weaveworks, Tunnel Probe, and 4 pods on this machine here. So now I click to this machine over here. And we can see here that it's running different containers. Okay. So these are the different containers that this machine is running for us. If I had to go and do that myself by hand, that would take a serious amount of work managing all this stuff, right? But again, by using this here, it does it for us automatically. So what I want to show you now is if I go into containers, Stephen tells me I have to wrap up soon, so I'll do that. Now what I'm going to do is I'm going to look at some of the containers that I have, and I'm going to look at the work that they're doing. So this one here is one of our main things, which is a worker. And if I go into this worker here, I can see all of the information about that particular system. I can also go in and I can execute a shell onto that system there, and it will allow me to interact with it directly. So all of this here I can do from within inside Azure Kubernetes service. And the reason I can do it from inside it is because all of the hard work is taken care of for me by Azure, by the Azure Kubernetes service. If I didn't have it managing all this for me, either A, I would have even less hair than I have right now left, or B, it just wouldn't be up there, because it is difficult to do, guys, right? So if you're getting into deployments, I strongly recommend that you consider using this for it. So let me just now finally wrap up and ask if anybody has any questions.